что, друзья, я предлагаю продолжать наше мероприятие. Все, надеюсь, успели пообедать и передохнуть, насладиться внезапной переменной питерской погоды, которая, возможно, даже настраивает на более рабочий лад. Мы фактически уже почти подходим к завершению, и в заключение мы проводим здесь, в этом зале, серию таких очень серьезных в формате глубокого погружения технических докладов от, пожалуй, ведущих специалистов, разрабатывающих непосредственно Postgres, которые будут рассказывать всякие разные вещи про internals и про оптимизацию и про возможности, которые можно для себя открыть, если знать немножко про то, как база устроена изнутри и что она позволяет делать. И первый доклад у нас будет от господина Альваро, который расскажет о том, как можно преобразовывать события DDL в некий понятный разработчику формат и что это позволяет делать, начиная от репликации и заканчивая всякими вещами типа аудита бизнес-правил, их поддержания и так далее и тому подобное. Just for the benefit of our speakers, I will reiterate my introduction in English. We are beginning a sequence of in-depth technical talks in here from our leading developers of Postgres, the most knowledgeable experts on the subject of PostgreSQL. And the first talk by Álvaro Herrera, who will give a talk about DDL representation in JSON format and how it allows to parse the JSON and present it in a way that allows to replicate data, review business rules and such. Álvaro, please.
Hello. Well, you already know I'm Álvaro. I work for Second Quadrant, a company that specializes in PostgreSQL services around the world. This is my first time in Russia, so forgive me for not speaking any Ruski. I find this a very nice city. Thank you for letting me come here. I didn't even need a visa to come here, which was a very nice surprise. So today I'm talking about capturing DDL events. Who here knows what DDL is? Okay, so quite a few. How many of you are interested in capturing DDL? Okay, so a few. This is perfect. So how can you actually capture DDL events? Well, the thing to use here is a new feature introduced in the 9.3 version of Postgres, which is event triggers. Essentially what this does is run a user-specified function when some event occurs in the database. And this is the syntax that we use to create an event trigger. Essentially you have create event trigger, the name of the event trigger, on event, then some additional process, and you have to specify what's the function you want to run when the event occurs. Now, what event are we allowed to capture? So we have DDL command start and DDL command end, which are related to what we're interested in, DDL commands. So DDL command start runs when a DDL command is called, but before executing the DDL command, and DDL command end is called once the command has been already executed. And we also have SQL drop, which I'm going to mention more about in a minute, and table rewrite, which I won't mention at all because it's not actually interesting for what we're doing here. And more events could be added in the future. It's very possible that new events will come in future releases. So what can you do when a DDL, when an event trigger is executed? Well, anything you can do in a function, essentially, which is a lot of things. Most people are going to use PGSQL functions to... sorry, I'm speaking too quickly. Okay. So most people are going to write functions in DDL, PGSQL, which is pretty familiar, I expect, to most people using Postgres. And you can write things in other languages. In particular, you can write functions in C, which is probably the most useful thing to do once we get to the end of the presentation, as you will see. And we offer some set return functions to run inside your PGSQL trigger handler to obtain some data. So suppose here we have an example. Here we create a function called snitch that returns type event trigger. The function that is run on the event trigger doesn't actually return anything, cannot actually return anything. But we need the returns event trigger so that the system knows that this is a function to be called during an event trigger execution. And there's a magic function, a magic variable that, as you know from other trigger functions, that is tg tag, which obtains the tag of the command that's being run. And then you can create an event trigger using this function, and whenever the DDL command and event occurs, this function is going to be called. So, for example, we can invoke create table, and then my function is going to run, and you say you obtain the log message. We got a create table error. So here we have the command that's being executed, right? But when this functionality was invented, there wasn't enough foresight to design something that was actually useful in the field. So we have this tg tag thing that's not actually representative of what's being run. Because if you use complex commands, such as this one, create schema, which inside contains some create table subcommands, then you only get the create schema tag, and you get no create table tag. So if you're trying to capture information about tables being created, then you can be fooled by obtaining by somebody running a create schema complex commands that contains create table commands that are not reported as tags. So initially, when the feature was invented, the idea in mind was that somehow multiple DDL command and events were going to occur in the database. So you would get 3 lines because the function would run 3 times. But this is not what actually ended up happening. So this interface isn't any good, actually. So this example is completely useless as an event trigger function that wants to capture the new. So we invented a more complex interface. And the first thing we did was handle drop events, because drop events were known to be easier than other things such as create and alter. So what we did there was invent a set returning function, which is pg event triggers dropped objects, that returns a set of objects being dropped by the command. So for instance, if you run drop table, then your SQL drop event trigger would run, and you could call inside your function this other function, and you would get this kind of result. Okay, so there's a number of columns which I am going to describe in a minute that you can read and do something with. For example, you can audit them. So the columns are these. You have first 3 OIDs, which are class ID, object ID, and object sub ID, which is a system internal identifier for the object based on OIDs. And you can look up the object on system catalogs using these OIDs. you have the object type, which can be table or schema or table column or whatever. You have a schema name, which is the containing schema of the object being dropped, or no, if the object is does not live within a schema. For example, if a schema is being dropped, then there is no schema. You get the schema name via the object name column, which is separate. So object name gives you the actual name of the object, such as the name of the table being dropped. And the object identity is a margin readable identifier for the object. We also have address names and address args, which are additional columns that represent the object that can be exported to a separate server that has an identical object. So the problem here is that you have the OID identifiers that supposedly are very useful to identify the object in the server, but keep in mind that when the SQL drop event trigger is run, the object has already been dropped, so it doesn't exist in the system catalogs. So you can't actually look up the object in the catalogs to know what object is being dropped. So that's why we provide the object name, the schema name, and the object identity, so that you can know what object was actually being dropped. Does this make sense? Okay, so we provide a couple of additional functions that you can use to obtain more information with the columns that you obtain from the SQL drop event. For example, you have the PG identify object to which you can pass class ID, object ID, and object ID, which, as I said, can be used to look up the identity of the object, but cannot actually be used that way because the object has already been dropped. So you can use PG identify object if you have the OIDs from somewhere else. Or, for instance, if you roll back the drop, then you can use the OID identifiers, and then the PG identify object is going to work. We also have PG get object address, which you can use to obtain these OID-based object identifiers by passing the object type, address names, and address args columns that were provided here in the SRR function. So the point of this particular function is that it helps to identify a similarly named or an equally named object in another server that contains a similar schema. For instance, if you're doing replication and you drop an object in one server, you can pass the object type, address names, and address args columns to the other server, and the other server can run pg get object address, and then it can use the identity of the object in that server to drop that object. Okay, so that's what BDR, for example, is doing. It transmits these columns to the other servers, and then the drop can be replicated. And so the schema is kept consistent in many nodes across a replication system. So, well, I already said that. Anyway, consider something like drop schema. If you drop schema, you may have many objects within the schema that are also going to be dropped. So this is why we return a set in the PG event trigger drop object function, so that we can report all the objects that are being dropped. So drop schema drops a lot of objects, and you're going to get one row for each object being dropped. And consider also another command such as drop owned by, which drops a lot of objects that are owned by some other some role in the database. So it is able to handle complicated cases by using an SRF. So I didn't mention this. We have original and normal columns here, and those are expressing something rather complicated in the system and how we manage objects. Original is true when the object is being mentioned explicitly in the drop command. So for example, if you use drop schema, the schema is dropped and you get original in the row for the schema, but also many tables are being dropped, and then you're going to get false for original in the rows for the tables or whatever inside the schema. We also have normal, and this one is a lot worse, because what this is indicating is whether there's some dependency between, some direct dependency between the objects being dropped and the other object reported in the setter returning function. So for instance, if you drop a type and you have a function that depends on this type, because for example the function takes that type as an argument, then you also need to know about that function if you try to replicate the drop in another server. So what's the problem here? The problem is that there are many object types for which you can't simply use a drop command to drop. For instance, a table has a toast table. Everybody knows what a toast table is, right? Okay. So if the table has a toast table, and if you drop the table, you're going to get a row of this for the toast table as well. But the toast table might have an internal name that corresponds to the OID of the other table. So if you go and replicate the drop toast table in another server, it's not going to work because it doesn't have the same name. So you need to know to ignore objects that aren't reachable via normal dependencies when you try to replicate. So that's why we have normal here. Normally, if you want to replicate a drop to another server, you need to ignore anything that's not normal. Okay. So I was saying consider drop on by that can drop a lot of objects. Well, I think I already said. So anyway, you can have, this is an example. Suppose you want to report a drop as it happens, what the event trigger code is going to look like this. You essentially have a loop on the function that I mentioned, and inside the loop you will get one log line for each object being dropped. So, well, you create the event trigger this way, executed on the SQL drop event. So this is an interesting example. If you do alter table drop column, you're also going to run an SQL drop event, and you're going to get a row that says the type of the object being dropped is a table command column, and the identity of the drop column is public myTable column. Okay, so if you want to replicate drops to remote objects, you not only have to you can't just execute a drop because in some cases you need to use alter table, such as for columns and constraints and other things. We had the other trigger which reported we got an alter table event, and then we see again that the tag that's being passed to the event triggers as each tag is pretty useless, because there's no way you can know what subcommand is being run inside this. So well, that's for drops. Drops were the simple case. This one is a bit more difficult. When you want to handle generic DDL events, such as create table and alter, create commands and alter commands. So we come up with another set return function. This time we called it PG event trigger DDL commands, and this function will return all commands that are being executed. And this is very interesting. You have again the class ID, object ID, and sub ID columns, and these columns are actually useful in this case because the DDL command end event runs after the command has been executed. So the OIDs are in the catalog once this function runs. So you can use them to look the object up. And you have the command tag, which is the actual command tag that's being executed. So for instance, if you have a create schema with subcommands, you're going to get create schema for one row and create table for one row and so on. You get the object type and the schema name and the object identity. Those are identical to what we have in the SQL graphing. And we have in extension, which is a boolean to indicate that the command is being run inside an extension script. So if you do create extension, you're going to get reports for not only the create extension itself, but also for all the commands that are executed inside the extension script. So if you're trying to replicate commands, for instance, what you want to do is only consider the one that has in extension set to true and ignore the ones that have in extension set to false, because they are going to be replicated internally once you replicate the create extension command in the auto server. I hope that makes sense. And finally, you have the command column. I'm going to talk a bit more about command in a minute. Well, I rarely said all this. So anyway, command is magic command. So you write a DDL command end function in this way. So PG event trigger DDL commands function runs exclusively inside DDL command end event, and if you call it anywhere else, you're going to get an error. So once you call it, you can show a message. We got such event for object such, the command tag and the object identity. So suppose we just call create table such. We get row, and now we have the correct command tag here. We have the identity of the table being created. So you can go to the catalog and examine the table or whatever. If you try the example, the complex example that we used before, suppose, well, I actually altered this a bit because I used a serial column here. So you create a schema, and inside the schema you create one table, and also you create another table, and this table has a serial number. So what you get is a create schema command for the actual schema. Then you create a sequence for the sequence that got created automatically by the serial column. And then you get a create table for the first table, and then you get an alter sequence, which is what links the sequence to the column so that it becomes a serial column. And then you get the other create table. So in this way, using this interface, you can actually obtain the complete information of what's being executed in the server. Regardless of the complexity of the command itself, you get a broken down representation of the thing that's being run. And hopefully, unless there are bugs in the implementation, you will get them in the correct order. So, for instance, the first implementation we had for create schema with subcommands reported the tables first and the schema at the end. So obviously that didn't work because you tried to create the tables before the schema existed. So we had to alter the way the schemas are reported so that it is created first. I cannot test all possible cases, but I can react to bug reports saying, hey, I tried this one and it didn't work. It showed me the commands in their wrong order. So if you find any case in which this is not working well, please let me know. And I will try to fix it. Or we will have to revert the commit. So I said we had a column called command, which is of type PG-DDL command. Now the PG-DDL command type is very special because you can't output it. There's no way to produce an output value for this, and you can't also produce input values for this. So you can't. There's no way to get anything out of that column except passing it to a C language function for further processing, and there's no way to produce that column except by having an event trigger produced from the SRF function that I described. So what I did was write some extra code that's not being committed to the core Postgres, but it has been published as an extension, in the email linked here. So if you go there, you can download a patch, and you can download an extension, and that allows you to construct something that can process the PG-DDL command thing. So the PG-DDL command is a pointer to a sysstruct, and the sysstruct looks like this. We have a collect command type, which is this, and this is the minimal number of values that we needed to represent any command in the system. So we have one for simple, and simple means almost anything that you can run as DDL command. We also have alter table, which is essentially something that alters a table and can have many subcommands inside. So the alter table case is here, and you see, can you read this at the back? Okay, well, anyway, you're going to have the slides somewhere later, so this is going to be, so alter table, you have the object ID for the table being altered, and you have a list of subcommands, and the list of subcommands is a list of these structs, and for each of these structs, you get an object address, which is defined here, which is the thing we had reported in the SRF functions. So you have a class ID, an object ID, and an object sub ID, which are the OID-based identifiers for an object. So you, at this point, you know what column or what constraint or what index is being involved in the alter table subcommand that's being called. And you have parse tree representation for the object, for the command, that you can examine to know whether this is an add column or an add constraint or drop index, whatever. Sorry, drop index is not an alter table. Anyway, you can also have, for example, grants and revokes, and then you get a pointer to another sysstruct that you can examine to know whether this is a grant or revoke, who gets new privileges, what objects are being changed. So, well, we have a simple alter table, grant, alter operator family, alter default privileges, create operator class, and alter text search config. which are the commands that needed some handling beyond what the simple representation have. So the simple representation is based on the parse tree again, which is the parse tree for the command. And you have an object address, and the object address is, for instance, the address of the table being created. And for some commands, you also have a secondary object, which is another object address. And for that one, you get, for instance, if you create a unique constraint, you are creating a unique index underneath. So you get one address for the constraint and another address for the index. So the command that's being parsed can know what's the index being created, not only the constraint. So if you write a C function, you can examine this and know exactly to every detail what's in the commands that are being executed in the system. So you can keep a very detailed audit log, for instance. Okay, so anyway, I don't think most people are going to write C functions for this, and writing it to produce some usable representation is pretty difficult. So we did it for you. And I already mentioned, I wrote an extension that allows you to get the PG DDL command column and produce some JSON. So the thing is, the thing you do here is you obtain JSON representation in your event trigger function, and then you can modify it, or you can leave it as is, and you can call another function that converts this JSON back to a normal command text command representation. So the JSON is a very nasty thing that looks like this. This is loosely based on sprintf. So you have this %s thingies, and each percent. This is I think we call this expansion specifiers or something. So you have, for example, %identity and a D, and this D means expand whatever it is here as a duple identifier, as a dotted identifier. So you have the identity, which means look up a property within the JSON object that has this name identity, and obtain the object within it, and use the values inside that to expand as a string. So in this case, what we're doing is create a table that's in the public schema and has the name T1. So if I were to expand this, I would get create table public.t1, and the system knows, because this is a domain specific implementation, that knows that it has to add a dot between these two members, and also that if there are funny characters in the name, for example, if you have a name within a space, it needs to add double quotes. So you have this FMT thing, which is for format, and it's like sprintf format, and it is expanded using the values in the rest of the JSON object, and this is recursive. So for example, you can have the inherits here, which is part of this format string here, and inherits is also an object and also has an FMT, and the format here is inherits open parent, the close parenthesis here, and you have another thing here, which is the list of parents. You have the colon, comma, space, which means if you have multiple items in this list, you need to separate them with comma space. So there, if you had any parents here, there will be .d elements, and each one of these is expanded as a dotted qualified name. So you get a list of fully qualified object table names. So this is rather complicated. But if you just leave it like this, you can eventually use the PG event trigger expand command function that takes a JSON object that was produced from this, and it is expanded to this. Okay, and you can also use the JSON set function and give it your JSON object and change whatever part of the JSON you had, and for example change the public to historical or to the time travel. So if Magnus was here, I could tell him that he could create his time travel schema by using an event trigger that takes this thing and changes the schema name here, and this automatically creates the time travel table for the normal table that the system is creating. So this is pretty powerful because you can do anything you want. So for instance, in PDR, to replicate DDL commands to other systems, we just take the whole JSON thing, expand it as text, and then give it to the remote server, and it is replicated there. So there are many pieces at work here, but I think this makes sense as a representation. Supposedly, our extension is able to handle all DDL commands in the system except for create transform, I think, which was introduced after we published the extension. Sorry?
We only handle database local stuff. So create database.
Oh, sure, of course. Right. So okay. So yeah, maybe I forgot to mention this. So event triggers are only act on local local objects. So you don't replicate. You can, for example, get rows from this for create role, because roles are global objects, or create database or create table space. You have to replicate or audit or whatever those commands in some separate way. So anything that lives within a database, such as a table or a function or a type, are going to be reported here by the system. So create transform is a local object, so that's the first bug we have. So to make it a bit more complex, for instance, if you create a table, somewhere in the format string you have this part with the table elements, and this is an array. So the table elements thing in the JSON block needs to be an array too. So we have an array. Within each element of the array, you have a format, and this format is pretty complicated because in particular we have the %t thing here, and this is for the type of the new column. So the type of the new column is here, and it represents as a type in the system. Types are pretty bizarre because you have some types that have names after the SQL standard, and you have other types that have internal names. So what we decided here was to schema qualify all types, and whenever it's a system type, we have a schema of PG catalog, and the type name is int4 instead of simply integer, because this works everywhere for anything. You have the isArray bit, which is in this case false because this column is an integer. But if I had, for example, integer array, the %type expansion knows to add square brackets to it. So it is turned into an array without having to put the square brackets here in the type name, because that would be ugly. And you have the tip mod, which is the type modifier which goes after, in parentheses, after the type name. So for example, if you have var 32, then you get the 32 number here, and you can process that if you want. Well, there are other clauses, but this is mostly same thing. So we have the following possible format escapes. We have %%, which expands to a %sign. This is necessary because otherwise it's not general enough. But I don't think there's any DDL command that can actually use %signs. So this is not necessary for DDL commands. So you have %I, which expands as a single identifier, for example, for a schema name. %D, which is a possible qualified identifier, so you have the dot in the middle. The T as a type. The O, which is an operator name, which is very similar to %D, except that there are no double quotes around the name. You have %L, which is a string literal, which is used for things like if you have a create trigger and you have parameters to the trigger, then each parameter is passed as a string literal. This is ugly, but it was needed so that we could make it work. %S, which is a single string without quoting, we use this for things like, for example, persistence unblocked here. The persistence is an S, so you need to create unlocked without any quoting. So that's the kind of thing that we use the %S. And %N, which is a simple number without any quotes. For example, if you create a function and you use the rows clause to say how many rows you expect the function to return, then you need to have the number without quotes or anything. And the %R is for row name, so you can have an actual row name or a specific, special row identifiers such as public or current user or current row. Actually, this is another bug now that I think about it, because the system allows current row since recently, and we didn't add this to the %R. So that's bug number 2 in the extension that's already published. Mostly if you just grab JSON as reported and use the expand function here, you can obtain the same command that you executed, except that now all names are qualified completely. The constraints are going to have their names in them, and such. I think that covers it. Yes.
In the format strings, you must use.
Sorry, hang on.
In the format strings, you use mostly capital letters, but a couple of them are lowercase.
Yeah, there's no particular reason for this. I just thought it made. Oh no, there's one reason for this. We have the %S I inherited from sprintf, right? And the ones that are uppercase, such as %L and %D, no, %L and %I inherited from the format function, the SQL format function in PostgreSQL. So you use format and have a %I there, and it expands and put the identifier. So I mimicked the same thing here, and some of those I just kept because it seemed consistent. For example, the person D was pretty related to person I, so I chose to keep it as a uppercase.
Thank you.
That's expression.
Thank you for your report. It's very interesting. What I would love to hear is how this can play together with logical replication string. Because sort of in what context the DDL end command are being run, and if we can inject this somehow into data change event stream we get from logical replication.
I think Andros Freund behind you can explain better than me. But I don't think we actually. I remember what we do. So what we do is we have a table, a special table in BDR, and we run the event trigger, and the event trigger inserts the expanded value into the table. And the table is a normal table, so it goes into logical replication, and then the other side receives it. And when it sees a new tuple for that special BDR system table, it knows it needs to read the command and execute it.
Okay. And it's sort of all the transactions that has committed before this data change, they are not dependent on the change is made in this transaction, sort of. So we're safe here.
That one I think it's better explained by Andres.
Okay.
The normal object locking takes care of that. Locks.
The normal locking around DDL prevents any problems around that, because while you hold the lock on, if you do an alter table that requires an exclusive lock on the, or depending on what you do, different type of lock, but that prevents concurrent modifications. So if you do then insert that into the queue table for DDL changes, nothing else can happen in between. So that's safe from a concurrency point of view.
If you handle the start event, can you prevent the execution of DDL command?
Yeah, the start event is pretty useless most of the time, except that you can check the command tag and see whether you want to raise an error, for instance.
Or can you modify it, actually?
The command? No,
yeah.
No. The start command, the start event doesn't get any useful information, because since the command hasn't been run, hasn't been processed yet, we don't know anything about it.
And if the start handler fails for some reason, does it corrupt something?
Yeah, the command is not executed.
Okay.
But there's no corruption. It's just aborts.
Okay.
Anything else? So I wanted to have some feedback on whether this is an actual useful representation for the actual applications that are going to exist. So if you try this and find it not to work for whatever reason, please write and we will see what to do.